Hey, hope you're doing well here. Going to march on today to section 2.8, solving inequalities in one variable. So if you have questions on the last homework assignment, please let me know so we can address those and I can help you out with that. Anyhow, so we remember what inequalities are: greater than, less than, greater than or equal to, less than or equal to 0, less than or equal to. It's easiest to figure out inequalities when you're comparing to 0, because when you're comparing a function to 0, you're essentially saying, is it above the x-axis or below the x-axis? All right. So we're looking for, if it's greater than 0, we're looking for where it's positive. In other words, where is it above the x-axis? If it's less than 0, it's where it's below the x-axis. So you might want to write down some notes here. Actually, you guys could probably print out these notes. I think I'm going to post the whole slideshow for you guys so you could print them out and fill in some stuff as you go throughout this and do it. Sorry, there's some scribble scrabble from the last class. Anyhow, so you guys can check out example 1 on page 236 in the book. I don't have my book with me, but I know that's the right page number because it's not the page in the old book that I have. So you can check it out. Might be something good to look at there. But anyhow, let's do example 1 here. Determine the x values that cause this function to be 0, positive, and negative. Okay. So first, let's just consider what this graph would look like, this functional graph would look like. That will kind of help you when you're determining this. Okay, so I see an x, I see an x squared, and I see an x. Now, if you multiply all these together, you would get an x to the 4th. Okay, and it is a positive x to the 4th because these three x's are all positive. So graphically, you have what looks like a parabola on the tails here. All right, so first, this is already factored for you, so you can just go ahead and set the factors equal to 0 and solve them to get the zeros of this function, or the x-intercepts of the graph, which my graph has vanished. Oh, it's back. Anyhow, now this middle factor, x squared plus 6, the reason why we didn't do anything with that is because if you move over x squared to the other side, you get a negative number. And when you take a square root of a negative number, you get imaginary numbers. So you don't really need to bother with that factor, because graphically that will never be 0. And that will not represent any points of switch between positive and negative as well. Those are the x-intercepts that would do that. Okay, so here are your two zeros, negative 3/5 and 1. So those are where the graph is 0 at. Okay. Now on the graph here, you would have at negative 3/5 an x-intercept, and at 1 an x-intercept. Remember, I said it was x to the 4th, so the tails are going to be like the YMCA guy. All right, and it's going to come down, go through here, and come up like that. It's like a parabola on steroids, essentially, is how you can think about that. All right, so let's continue. And now, where is the graph greater than 0 at? In other words, where is it above the x-axis? And that is the tails, okay, where it's less than negative 3/5 and where it's greater than 1, okay? And the x squared plus 6 part is always going to be positive. So really, you're just concerned with the tails of the graph. All right? So there you go. And where is it less than 0? Well, you probably would have guessed it's in the middle, okay, where it sinks below the x-axis. All right. Now, is there a way to do this without the graph very easily? And the answer is yes. There's a way that we can do this without a graph, and that's by making something called a sign chart. That's what we're going to show you here soon. Okay, so here we have another function. It's greater than 0. If you think of the graph, it would be an x cubed graph. And so it's kind of like the disco guy. One arm is down on the left, and then it rises to the right there. But before we figure out the zeros, we should go ahead and so when you are making a sign chart, you need to determine the zeros, okay, the zeros, or if there's any vertical asymptotes of the function. So we're going to factor this, okay, because guess what? This does factor further here. So we have 2x minus 7 and x minus 2 squared greater than 0. All right, so let's find the zeros. Oh, I already did it. 7/2 and 2, okay? Set each factor equal to 0 and solve to get the zeros. All right, so this is what the sign chart looks like. You put the zeros or vertical asymptotes on little lines here, and these lines separate regions of the graph where it's positive or negative potentially here. Okay, and I put 0 above here to identify that these are indeed 0. All right, so now what you want to do is pick a value that is less than 2 and substitute it and consider the signs, okay? So like for instance, I would pick, say, let me get a different color here. Blue, okay. Ooh, got some weird words that popped up there. Okay, I would pick, say, 0, because 0 would be in this region, okay? And I'd substitute it in for x here, and I'd consider what the signs would be. So I put 0 into for this factor. I would get a 2 times 0 is 0 minus 7. I don't really care what the number is. I know it's going to be negative. They call it a sign chart because you put the signs of what you get here. So this is a negative sign. Now if I put 0 into this factor, I'd have 0 minus 0 plus 4. So this is positive. Okay? So the overall sign of this region would be a negative because I have a negative times a positive. So this region would have a negative sign in it. Okay? Next, I want to pick something between 2 and 7/2, which is 3.5. Okay, so what I would do is probably pick the number 3. Okay, so if I put the number 3 in here, I get 2 times 3 is 6. 6 minus 7 is -1, so that part is a negative. I put 3 in here, it's a little bit harder. 3 squared is 9. 9 minus 3 times 4, so that's so you might need to write it out a little bit. 9 minus 3 times 4 is 12 plus 4. Okay, so I end up with 13 minus 12. This part here is also positive, which is interesting. All right, so really this region here is negative as well. Okay, and now graphically the reason why that this is negative as well, okay, this is the graph from the previous one. It's because we have a double root or a double 0 at x equals 2. And so rather than passing through the x-axis, it hits that value of 2 and it bounces back. So graphically, the function comes up here, smacks this point, bounces back, and then later on breaks through like that. Okay, the one tail is down and the other tail is up. So this 2 point is not a separation between positive and negative. It's really just a bounce point for the graph here. And so you have 2 negative intervals. All right. And then for this last region, you can pick something greater than 3.5. So like maybe 4 or 5. Okay, then you'd substitute and do the same thing. So let's just summarize this again with making it a little neater. So the other thing is, okay, the way that they did it is they actually substituted into this part here, and they still get a negative region because a negative squared is a positive, so you still have a positive times a negative, which is a negative. Okay, so here they're substituting it into the factored version of it rather than into the original function. But that's okay. You can put it into either one. It doesn't really matter as long as you get the signs right. Okay, so we had 2 negative regions, and this last region here you might expect is all positive, okay, because that's that tail that's going up. All right, so where is this graph greater than 0? You would summarize it by saying x greater than 3/2, 3.5, or 7/2 to infinity. Okay, so there you go. That's your first instance of a sign chart. Hope you appreciate that. All right. Next function here, we're going to solve this one graphically, but you could also make a sign chart with it. It's kind of hard to make a sign chart for this one unless you can factor it correctly. And you can factor this one by grouping. If you group the first 2 terms and factor out a GCF, and you group these terms and factor out a -1, then you can get it. But if you just do it graphically, it's okay. If it's hard to factor, you just look at the graph and figure out where is it greater than or less than 0. Here it's less than or equal to 0, so we're going to be using brackets rather than parentheses if we're doing interval notation. All right, so this is what the graph would look like. You have 3 zeros here. Okay, so we're looking for where it's less than or equal to 0. So basically, the parts you're considering are each of these sections below the x-axis. So here and between here and here. Okay? So, it's already highlighted there. Okay, so like I said, we're using brackets. So this first interval is there. Union 1 to 4. Okay, and we'd have that in brackets because when it's less than or equal to 0, we show that we include it by using brackets. All right, now let's extend this to rational inequalities. Okay, rational inequalities, basically the same thing, only we have to consider vertical asymptotes. We have fractions, polynomial functions that are fractions here. Okay, so it could be undefined. That's the only thing that we're really adding. It could be positive, negative, 0, or undefined. And here's a good example if you check it out in the book, which, it's good to look at some extra examples. So go ahead, pause the video, check it out. All right. So you cannot clear fractions if you want to try to get the variable by itself in an inequality because you don't know whether or not to flip the sign. If you try to clear the fraction, you have to split it up into cases, which is a little bit messy. So anyhow, that's just a word of advice. I don't know if you'll have to tackle any problems like that per se, but here you go. We're going to determine this rational function where it's 0, undefined, positive, and negative. So the best way to do that is create a sign chart. So we're going to create a sign chart for this. Okay, so first the zeros come from the numerator where the top is equal to 0. Okay, so x equals 1 would be the x-intercept of where the graph would be 0 at. Where it's undefined come from where you get division of 0 here. And also, because there's a square root here, it's going to be undefined below a certain value because of imaginary numbers. You can't have negatives underneath the square root. So you have 2 values to worry about, or 2 areas to worry about. X equals 4, that will give you division of 0. And x less than or equal to negative 2 would be undefined because that would be the square root of 0, which gives you 0 on the bottom if you put negative 2 in. Or if you put anything less than it, you get an imaginary number. Okay, so here is your sign chart setup. So UND, this is UND for undefined. Okay, so you put the undefined regions and the zeros, and you want to make sure to set it up in order from least to greatest on here. Okay, so now pick a number in the region, like say negative 3, and substitute it, and consider the signs. If we put negative 3 in here, though, we get an imaginary number, so this whole region is undefined. Okay. Now, between negative 2 and 1, you could pick an easy number, like say maybe 0. Put it in for this. That would be a negative on top. So you'd have a negative there. You'd have another negative there. And you'd actually get a positive there. Okay. So this whole interval, you would have 2 negatives that would cancel to make a positive. So this whole region would actually be positive. Okay. So if even amount of negatives, it's going to become a positive region. Okay, provided there's no squaring or exponents, of course. So here we have pick a number like maybe 2. You'd have a positive value on top. You get a negative there, and then you get a positive there. So this region is negative, and then over here it's all positive. So pick like 5 and put it in. Okay, so letter C is the positive regions, okay, between negative 2 and 1, or 4 to infinity. And letter D is the negative regions. Okay, so that's about all I can fit into this video. We will give you another video tomorrow with some more of these problems explained to you. and some problems to do. So have a great day, guys. Bye-bye.